Hello everybody, it's Mrs. Pound and I am back with another chapter, chapter 2 on the chemistry of life. And in the first section, 2A, we're going to talk about basic chemistry. This is a really important chapter because living things are made of chemicals and there are a lot of chemical reactions that happen in living things. So it is very important to have a basic understanding of chemistry, and this should be review. So let's start with matter from section 2.1. Our objectives are going to be to define matter and energy, describe the structure of an atom, distinguish between an atom, molecule, compound, and mixture, describe ionic and covalent bonding, and differentiate between chemical and physical changes. So let's first start with a statement. The two basic components of the physical universe are energy and matter. And of those two, today we're going to focus on matter. So matter is anything that occupies space and has mass, just like all of these things in the background. They are all matter because they are taking up space, and if we were to put them on a balance, we would discover that they have mass. There are three normal states of matter. They are solid, liquid, and gas, and we can see all of those states in this picture in the background. We can see the ice on the shrubbery here at Niagara Falls. We can see the water going over the falls. And then here, now this is technically a liquid because it's the condensation, but in order to be the liquid, it had to evaporate. So there is also gas present around that area as well. Now, when we talk about chemistry, we talk about the elements from the periodic table. And an element is a substance that cannot be broken down into simpler substances by chemical reactions. And in the background, what you're seeing are iodine crystals. And so those iodine crystals are one of the elements. Elements are made of atoms. An atom is the smallest unit of an element that can exist either alone or in combination. And one type of atom makes up an element. So elements only contain one kind of atom. There are other things that contain more than one type of atom, but elements are always just one atom. Atoms can be broken down into smaller particles too. And if you recall, one of those particles in the nucleus of an atom is the neutron. This is the non-charged particle in an atom's nucleus. It's called a neutron because it's neutral. It has zero charge. Okay, zero charge. Also found in the nucleus of an atom is a proton, and a proton is the positively charged particle in an atom's nucleus. So these are positively charged, and it is the neutrons and the protons that give the atom most of its mass. Okay, most of the mass in an atom is in this nucleus. There are also electrons, and this is the part of an atom that has a negative charge and that moves in a shell-like orbit around the nucleus. So the electrons would be found out here. They're very small in comparison to the protons and the neutrons and contribute very little mass. Now, what we also have to understand is that matter consists primarily of empty space. The mass is mostly concentrated in the nucleus, and then if you look at this, there's a lot of empty space, and the electrons would be very small, whizzing around very fast around that nucleus. So they are, in fact, mostly empty space. Now, we can also have what are called isotopes. And an isotope is one of the forms of an atom produced by having different numbers of neutrons, but the same number of protons in the nucleus. And an important thing we need to know about isotopes is that they have the same chemical properties. And an example is carbon-12 and carbon-14. Now, if we look at these, this number behind it, that is the mass number. Okay, the mass number is the number of protons and neutrons. And we can see that those mass numbers are different. But because both of these are carbon, they have to have the same number of protons, which is 6, but they have different numbers of neutrons. Carbon 12 has 6 neutrons, and carbon 14 has 8. And so they have different numbers of neutrons but the same number of protons, and they do have the same chemical properties. When we talk about chemistry, a lot of times we also talk about bonding. And there are 2 types of bonds we're going to talk about today. The first is ionic bonding. This is giving or taking of electrons. And I have salt in the background because salt, one of the characteristics of salt is ionic bonding. And ionic bonding contains ions. This is an atom or group of atoms that has a positive or negative charge as a result of losing or gaining electrons. So if an atom loses an electron, it becomes positive and it becomes a positive ion. If it gains an electron, it becomes negative and becomes a negative ion. And we know that opposites attract. So that positive and negative ion, they will come together and form an ionic bond. And so salt does that. And I have a picture. This is actually from the Dead Sea in Israel. This white stuff is salt, but salt is dissolved in that water. That is a characteristic of ionic bonds, is that they will dissolve in water like that. Many of them. And when they do that, they break up into their ions. So NaCl, sodium chloride, table salt, will break up into a positive sodium ion and a negative chloride ion. So we have Na positive plus Cl negative. There are also covalent bonds. Now, a covalent bond is a chemical bond formed between atoms as a result of sharing a pair of electrons. So instead of completely transferring the electron, it's shared, okay, in the bond. And an example is water, H2O. H2O. These are covalently bonded. It will not break up into H positive and O negative or O2 negative ions. It does not do that. It is sharing those electrons. Now, when we're talking about chemistry, we also talk about molecules. This is the smallest possible unit of a substance that consists of 2 or more atoms. So our water, H2O, that's a molecule. Also, gases like O2, oxygen, are molecules, okay, because naturally they occur as 2 oxygen atoms bonded together. The same thing with hydrogen in the atmosphere, carbon dioxide as molecules. Now, elements can be molecules, but they cannot be compounds. Okay, so a compound is a substance composed of 2 or more elements chemically combined in definite proportions. So oxygen, O2, is not a compound, that is an element. However, water, H2O, because it's 2 or more elements, is a compound. So molecules can be compounds or elements, okay, but a compound is a molecule. So I know that sounds a little tricky. I'm not going to test you on that, but just something to think about. An example of a compound is glucose, C6H12O6. So that's glucose. That is sugar. When we look at this formula, this is a chemical formula, we have subscripts behind the letters. The 6 means that there are 6 carbon atoms in glucose. The 12 behind the H, 12 hydrogen atoms. And the 6 behind the O, 6 oxygen atoms. So when we add those up, we actually get 24 total atoms in this molecule. There are 6 carbon atoms plus 12 hydrogen atoms plus 6 oxygen atoms, a total of 24 atoms. Now, going back to the H2O, Okay, H2, so 2 hydrogen atoms. O, it's just understood that there's 1. We don't write the 1. It's kind of like math where we don't write the 1s as exponents and out front or anything, but it's understood that the 1 is there. In chemistry, we also have chemical changes. This is a change in which a substance loses its characteristics and changes into one or more new substances. Some common chemical changes that happen in biology are photosynthesis, respiration, and combustion. So that's when we come up with new things. For example, in photosynthesis, we start out with water and carbon dioxide and we make glucose sugar. Okay? And respiration is actually the opposite process. We start out with glucose and end up with carbon dioxide and water. Okay? So those are chemical changes where we have different substances. There are also physical changes. This is altering a substance in its state of matter and appearance without changing it into a new substance. So for boiling water, we start out with water, we get steam, but it's still water. Same thing with the ice in the background. They're all forms of water, even though they look different. Mixing sugar and water. Okay, we mix those together. We don't end up with anything new. We still have sugar and water, even though we can't separate it unless we boil it and evaporate. And chilling gelatin. When we make gelatin, we dissolve it in water. We still have gelatin in water, and when we chill it, it hardens up, but it's still the same thing. We have not produced a new substance. And then finally, mixtures are important. This is a material that contains 2 or more substances. And some common examples are salt and water, sand and water, and a salad. Okay, remember salt and water, we call those homogeneous mixtures because we can't see the 2 different parts. Sand and water would be a heterogeneous mixture, and also salad because we can see the different parts easily. So mixtures are very important in biology as well. So our objectives today were to define matter and energy, describe the structure of an atom, distinguish between atom, molecule, compound, and mixture, describe ionic and covalent bonding, and differentiate between chemical and physical changes. So don't forget your 5 questions in your margin and keep watching this video because you have some questions to answer.